Black holes are some of the most fascinating objects in the universe. They're regions of space-time where gravity is so strong that nothing, not even light, can escape. Imagine a place where the fabric of space and time is stretched to its limits. That's a black hole. These enigmatic objects form when massive stars collapse at the end of their lives. They leave behind a core so dense that it warps the fabric of space-time, creating a gravitational pull so intense that it swallows everything in its vicinity. But don't let their darkness fool you. Black holes are anything but empty. They're thought to hold secrets about the nature of gravity, the evolution of stars, and perhaps even the ultimate fate of the universe. Think of them as cosmic vacuum cleaners, relentlessly pulling in anything that gets too close. But what happens if you do get too close? Let's take a journey into the heart of a black hole. One of the strangest things about black holes is their effect on time. Einstein's theory of relativity tells us that time is not absolute. It is relative, meaning it can be affected by gravity. As you get closer to a black hole, the immense gravitational pull starts to warp time itself. Time slows down for you compared to someone watching from a safe distance. This phenomenon is known as time dilation. Imagine you're falling into a black hole and you have a watch. From your perspective, time would seem to tick normally. But to someone observing you from afar, your watch would appear to slow down, then eventually stop altogether. It's as if you're frozen in time, forever hovering at the edge of the abyss. This bizarre effect is one of the many mind-bending consequences of Einstein's theory of relativity. Let's imagine the unimaginable. You're falling into a black hole. What would you experience? As you approach the black hole, you'd be met with a gradually intensifying gravitational pull. You would begin to accelerate faster and faster, towards the point of no return, the event horizon. The event horizon is the boundary beyond which nothing can escape the black hole's clutches, not even light. Once you cross this invisible line, there's no turning back. You're trapped forever. But here's where things get really interesting. As you fall deeper into the black hole, the difference in gravity between your head and your feet would become increasingly extreme. This gravitational gradient would stretch you out like spaghetti, a process scientists call spaghettification. It sounds gruesome, and it would be, but it would also be an incredible spectacle. You'd be treated to a dazzling light show as the entire universe appears to warp and distort around you. Now, let's shift perspectives. What would someone watching you from a safe distance see as you fall into a black hole? They wouldn't see you get spaghettified or disappear instantly. Instead, they'd see you falling slower and slower as you approach the event horizon, your image becoming increasingly redshifted. This redshifting is caused by the intense gravity of the black hole stretching the light waves coming from you, making them appear redder and dimmer over time. Eventually, you would fade completely from view, frozen in time at the edge of the black hole. But here's the catch. You'd have already crossed the event horizon and met your fate long before you disappeared from the observer's view. This discrepancy highlights the mind-boggling nature of time dilation near a black hole. The study of black holes allows us to probe the limits of our understanding of the cosmos. These cosmic abysses serve as a reminder of the vastness and mystery of the universe, beckoning us to continue exploring and unraveling its secrets.